Ionic compounds are compounds formed between two or more ions. These ions have to be positively and negatively charged, because opposite ions will attract each other, whereas charges that are the same will repel each other. Knowing what we know about ions from this chapter, hopefully you can figure out that we're going to have a metal with nonmetals, or multiple metals with nonmetals, in order to form compounds. So you'll almost always see me referring to metals and nonmetals. Just keep in mind where those two things are on the periodic table in this video. We've talked about splitting up the periodic table in multiple parts in an earlier video, and in this video I'm going to show you even another way to split up the periodic table, and you'll hear me refer to this way probably most often in this class. The second way to divide the periodic table is called dividing it up into main group versus transition metals. The main groups on the periodic table are groups 1 and 2, and then over on the right hand side groups 3 through 8. So that's the main groups of the periodic table. When I talk about the main group metals, I'm talking about group 1, group 2, and group 3 metals, because you'll remember that everything past here are nonmetals. So that's one grouping, and then the second grouping are the transition metals. So all of this stuff over here and these inner transition metals. So the second way that the periodic table can be split up is from main group and transition metals. Whenever we're forming ionic compounds, all of the plus charges, when added up with all of the negative charges, always have to equal 0. In other words, all ionic compounds are neutral in their charge. They have no overall charge. So we need to make sure that we always have enough positive charges to offset the negative charges to make them 0 or neutral. Remember that ionic compounds are always going to deal with metals and nonmetals. The metal in the ionic compound always comes first in the formula, and then the nonmetal. An example of this that you're probably used to seeing is sodium chloride. Notice sodium is a metal, and that comes first, and then chlorine. You've never seen it written as ClNa, because there the nonmetal would come first. And we always put the metal first and then the nonmetal when writing ionic compounds. Now I'm going to show you the shortcut for coming up with ionic compound formulas. If you're ever given a name, let's start with sodium chloride, because we just saw that a second ago. The way you can determine what the formula is, if you ever see a metal in the name, what you need to do is draw a squiggly line down the middle, and then write out the ions for both of these things. The sodium ion looks like Na plus 1 because it's in column 1 of the periodic table, and hopefully you remember that chloride is Cl negative 1 because it's in group 7 of the periodic table. The actual shortcut for coming up with compound formula involve these numbers here, not the charges but just the numbers. Once you know those numbers, if you crisscross them over, that will tell you the subscripts. Remember that you're never ever going to include the charge, the plus or the minus, in the subscripts. Only the numbers go down, which is why I circled only the numbers, and you notice that I left out the negative and the positive when I circled those numbers. So the charges never go down at the bottom. As far as writing subscripts, we also never write 1 as a subscript. For example, in a previous video I told you about water. and the 2 we write, but there's only 1 oxygen, and you'll notice that we never write that 1 oxygen. So the 1s we are never going to write down at the bottom. Instead, we're just going to leave that area blank, kind of like an H2O. Anytime you're doing this and the numbers for the metal ion and the non-metal ion are exactly the same, all you need to do is just shove the 2 elements together without actually bringing anything down. So sodium chloride, because they have both charges of 1, even though one is +1 and the other is -1, we're going to write it as NaCl with nothing down at the bottom on either of the subscripts. So that goes for the fact that if they're both 2s, if one is +2 and the other is -2, still you're not going to bring those subscripts down. You're just going to shove the 2 elements together. Or let's say if they were both 3, then you wouldn't bring any subscripts down. You would just shove the 2 elements together. Now let's take a look at a few practice problems that I have for you. The first practice problem says, write the formula and the name of the compound formed from aluminum and oxygen. Okay, so we know that aluminum, let's see here. Aluminum makes a +3 charge because it's in group 3A, and we know that oxygen, which is a nonmetal, makes a -2 charge because it's in group 6A. Now remember, the shortcut says to circle the numbers, not the charges, just the numbers, and then crisscross them down. Now remember, we're crossing these over because they're different numbers. If they were both the same, we would not do that. And that leaves us with the formula Al2O3. So that is the correct formula of aluminum and oxygen. And I just want to go back to this idea of the fact that all ionic compounds are neutrally charged. If there are 2 aluminums and each aluminum has a +3 charge, that means we have a total of 6 plus charges from the aluminums. And if we have 3 oxygens, each oxygen we said was -2 charge, so 3 oxygens is going to be -6. Now the thing I want you to notice here is that if you add up both of these charges, you get 0. And that's all we're doing with the shortcut, is making sure that our charges counteract each other so that we have an overall neutral charge of 0. Now the second part of the question asked us to name this compound. Whenever we're naming ionic compounds, we always name the metal first. So in this case, that's going to be aluminum. And then we always name the nonmetal with an "ide." So that's going to be oxide. So the name of this formula, Al2O3, is aluminum oxide. Alright, let's go ahead and do this next example. It says write the formula and name for the compound formed from potassium and chlorine. If you look at your periodic tables, there is potassium and there is chlorine. So potassium, because it's in group 1, remember I told you on every periodic table you ever get, you should write +1, +2, +3, -4, -3, -2, -1, and then 0, and that will help us with the charges of everything. So we know that potassium has a +1 charge, and we know that chlorine has a -1 charge. So to do the shortcut, let's go ahead and circle the numbers, not the charges, just the numbers, and then we would normally crisscross these down. But in this case, because these are both the same number, we're just going to shove the 2 elements together. So our final compound is just KCl. And this is called potassium, because that's the name of the metal, and then Cl is going to be chloride. So all ionic compounds are going to end in "ide." That's potassium chloride. Let's take a look at the next example. So the last example on your sheet says write the formula and the name of the compound form for magnesium and oxygen. Just let's take a look at the periodic table again. Okay, so we're dealing again with magnesium and oxygen. There is magnesium and there is oxygen. And remember, every time we have a periodic table, we're writing +1, +2, +3, -4, -3, -2, -1, and then 0. So magnesium is going to be +2, and then oxygen is going to be -2. Now to do the shortcut, we're going to circle the numbers, not the charges, just the numbers, and then we're going to crisscross them over. In this case, again, I've given you numbers that have the same value, so 2's. So that means we're not going to actually bring the numbers down. In other words, if you put an answer on a quiz or a test that said Mg2O2, this would always be counted wrong. What it actually is just MgO. So that's the formula, that's the correct formula. And then the name of that guy is going to be magnesium oxide. So again, just the name of the metal, magnesium, and then the name of the nonmetal with "ide." So magnesium oxide is MgO.